So this setup is for sieve analysis, right? So you have a stack of sieves. Topmost will be 2.36 millimeter aperture, then 1.18 millimeter, 600 micron, 300 micron, 150 micron is 0.15 millimeter, 75 micron then 0.075 millimeter, and finally pan. Right. So in that you have to aperture means your opening in the sieve. Other details will let you know. So opening in the sieve, and on the topmost again soil should be dry, and preferably 4.75 millimeter sieve you should be using, because sand, that's what you. So this 500 gram you take and keep it on the topmost, right, sieve on that stack. Then you keep the cap, and then it is kept in the vibrator, right? So that vibrator you can see, and then let us say 8 to 9 minutes you should vibrate. So 8 to 9 minutes, you see that he's making a firm connection, right? So firm connection, and then it is properly, and then he will start the vibration. It is around 8 to 9 minutes, right? That electrical connection, everything is there, right? So anyway, you can just then no, actually, so you see that he started the vibration like this around 8 minutes. Then you take out and take the weight on individual sieves, right, including the weight in the pan of the soil. So of course this summation should come out to be 500 gram, but if it is less than 500, even 490 to 500, that also we can take. Less than 490 combined if you're getting, then you have to repeat. And if it is exact 500, no problem, or 490 to 5, no problem. You just take the weight, and that weight you just measure on each sieve. And if it is less than 500, you can just add some numbers at individual spaces to make it 500. It's one technique. Or when you find out the percentage, you take the combined weight exact 493, 494, whatever it is, and find out the percentage. So you have to record weight retained on each like this, then percentage retained, which is weight on each, divide with the combined, and that combined will be your pan weight also, right? Then after required correction, right, then cumulative percentage retained. For the first one it will be as it is, for the second it will be summation of first two, for the third will be summation of first three, like this. And then 100 minus each, right? So 100 minus each gives you the cumulative percentage finer. And when you're finding out the cumulative percentage finer, finally you just have to exclude the pan part, right? Only 35 micron till that percentage finer, and those percentage finer on the linear y-axis upwards, and particle diameter on the logarithmic x-axis, right? So logarithmic x-axis, and that logarithmic could be increasing left to right or decreasing left to right, doesn't matter. You get the data points of a particle size, which is the sieve size, and percentage final linear increasing on the linear y-axis vertical, right? And the grain size distribution curve, the data points, manually you draw the smooth curve, right? And then from there you have to determine D10, D30 and D60. D10 is your 10 percentage finer, horizontal you move, then corresponding diameter you find out from the curve. That is your D10. Like this, D30 and D60, then coefficient of uniformity is D60 over D10. And coefficient of curvature CC is D30 square over D10 into D60. And if your CC is between 1 and 3, including 1 and 3, and CU greater than 6, because you'll be using sand. So if it is both conditions, if it is satisfied, then it is well graded, right? Otherwise it is poorly graded. So you have to classify the soil also. So this entire is your third experiment, right? About 4 minutes 55 seconds it has taken, but I'm just stopping. Okay, we'll move on to the hydrometer.